Hey everybody, hope everybody's enjoying their Saturday evening. Just wanted to record this video. This is exactly what I'm going to teach on Monday. So if you watch this pre-calculus video today, then on Monday you can just jump right into the homework and just have really another work day right in class. So that might be an avenue some of you want to take. If so, please watch this video. So Monday we're going to pick up with something a little bit new. You all learned way back with Miss Fain about SOHCAHTOA, and we have already talked about. Oop, my pen cap just fell down. Grab that real quick. Excuse me. We have already talked about sine as opposite over hypotenuse. We've already talked about cosine as adjacent over hypotenuse, but now we want to talk about tangent, which is opposite over adjacent. Let me draw a right triangle just so everybody remembers. Here's the hypotenuse, here's opposite, here's adjacent. So tangent is opposite over adjacent. That's really all there is to it, and now we're just going to use this definition to derive another formula. So sometimes we may not have the triangle given to us, but tangent is also equal to something else. So if you take a look here, tangent of theta is also equal to sine of theta divided by cosine of theta. People are often stunned when we tell them this relationship. People are like, how does this work? And I said, let me prove it to you right now. Let me just focus on this side. I'm going to make this side equal this side. Watch this. Tangent of theta equals sine. Sine is opposite over hypotenuse. Divide, what is cosine? Cosine is adjacent over hypotenuse. So I have one fraction divided by another one. So I'm going to keep change, flip. This hypotenuse cancels with this hypotenuse, and I have opposite over adjacent. And opposite over adjacent is exactly what tangent equals. So in other words, another way to think about tangent is instead of opposite over adjacent, tangent is just sine over cosine. So here's the proof, and some people might be like, why is this even helpful? The reason this relationship is helpful is because now, if you know the unit circle, which means you know the sine and cosine of the angles on the circle, then you can find the tangent of any angle on the unit circle. Let me give an example. If I said, what is the tangent of 30 degrees, I would say, well, tangent of 30 degrees over cosine 30 degrees. And I think it's helpful to write this in different colors. So let me start doing that. Sine of 30 degrees is 1/2. Then I've got the big divided by cosine of 30, which is √3 over 2. Now what does this equal? This equals keep the 1/2, change division to multiplication, and flip √3 over 2 to 2 over √3. Right, now do some algebra. The 2 goes away, the 2 goes away, and I have 1 over √3. Now I don't like 1 over √3. I want to get rid of the radical downstairs. So as Mr. Kurth taught you, you multiply by fancy 1, √3 over √3, and I get √3 over 3, which is the tangent of 30 degrees. Let's do another example. Let's do tangent of 3 pi over 4. Let's do tangent, sorry my phone is going off, tangent 3 pi over 4. So again, that is equal to sine 3 pi over 4. We close the parentheses. Divided by cosine 3 pi over 4. So What does that equal? Well, sine of 3 pi over 4, 3 pi over 4 is in quadrant 2, 135 degrees, that's root 2 over 2. Cosine of 3 pi over 4, that's in quadrant 2, so that's negative. Cosine of root 2 over 2 is negative root 2 over 2. And now you are going to keep, change, flip, and this equals, 2's go away, root 2's go away, negative 1. Tangent of 3 pi over 4 is negative 1. Let me do a couple more examples. Next example is tangent of 210 degrees. Tangent of 210 equals sine 210 divided by cosine of 210. What does that equal? Well, sine of 210, that's in quadrant 3, so it must be a negative value. Sine of 210 degrees, sine of 180 this is going to be negative 1/2. Divided by cosine of 210 is negative root 3 over 2. I'm going to keep, change, flip. It's fraction divided by fraction. Keep the top one. Change division to multiplication. Flip this. And now the algebra starts. The 2's go away. The negative signs go away. So I have 1 over root 3. Another way of saying that is, as we just typed on the previous problem, multiply by the fancy 1. Root 3 over 3. Finally, the last one I want to model here is tangent of pi over 2, which is equal to sine pi over 2 divided by cosine of pi over 2. Sine of pi over 2, top of the circle is 1, divided by 0, which equals does not exist. We have a does not exist because the denominator equals 0. Alright, so that's how you find the tangent of an angle. Now let me push forward. So the next thing we're going to say is, well, if we can find the tangent of angles, I guess the next thing we could do is draw the graph of tangent. Just like we do the graph of sine and cosine, we can draw the graph of tangent. Let me get some new colors for this. You guys know I just love this Black Friday purchase I had of the colors. Whoop! I'm finding a color in here without the marker. Without the cap. Let me close that up. All right. So to draw the graph of tangent, I'm just going to draw my axes. We'll put 0, put pi over 2, we'll put pi, 3 pi over 2, 2 pi. On this side we'll put negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Alright, so let's see what we find out here. Let's just plug in these important points. So, tangent of 0 equals sine of 0 divided by cosine of 0. 0 divided by sine of 0 is 0, divided by 1 is 0. So we go through the origin. Very nice. The next thing is, let's find the tangent of pi over 2. We just found that the tangent of pi over 2 does not exist, so we have a vertical asymptote here. What about the tangent of pi? Well, the tangent of pi is equal to what? Well, tangent of pi is sine pi over cosine pi which is 0 divided by -1, which equals 0. So the graph must touch right here. And in fact, we know, by the way, folks, tangent of 2 pi, sine of 2 pi, divided by cosine of 2 pi, sine of 2 pi is 0, cosine of 2 pi is 1, 0 divided by 1 is 0. So we know this happens here. At 3 pi over 2, tangent is equal to undefined. Why? Tangent of 3 pi over 2 is sine 3 pi over 2 divided by cosine 3 pi over 2. Cosine of 3 pi over 2 is 0. Anytime the denominator is 0, we have a vertical asymptote. We'll also have vertical asymptote at negative pi over 2. Cosine is 0 at negative pi over 2, and at negative 3 pi over 2. So tangent has 4 vertical asymptotes from negative 2 pi to 2 pi. The question is what happens in between this, and really all the graph does is it comes down here, comes up, and comes up. And then you have the branch here, which is what? Starts from the bottom, comes up, there you have it, starts from the bottom, comes up, it's going to keep going. What happens here? Well, similarly, the branch here is going to do what? What is going to happen in here? Well, if you don't know, like I've actually, honestly, I'm not exactly sure what's going to happen here. I know we're going to touch 0, but I don't know if it should go this way or should it go this way. Well, let's find out. What is the tangent of some angle in here? So what's an angle between negative pi over 2 and negative pi? I don't know. What's the tangent of negative 3 pi over 4? Let me do this on a separate sheet of paper. So negative 3 pi over 4 is right in here. So what is the tangent of negative 3 pi over 4? That's equal to sine negative 3 pi over 4 over cosine negative 3 pi over 4. Sine negative 3 pi over 4 is negative sine of regular 3 pi over 4. Cosine of negative 3 pi over 4 is just cosine of regular 3 pi over 4. Remember your even and odd properties. Sine of 3 pi over 4 is root 2 over 2. Negative 1 is negative root 2 over 2. Divided by cosine of 3 pi over 4 is negative root 2 over 2. So this equals 1. So the tangent of negative 3 pi over 4 is 1. So negative 3 pi over 4 is right in here. The tangent value is 1. Therefore, we must come like this and go up. And similarly, what must happen? We must come like this and go up. And there we have it. Now, we can start to make some conclusions. Where will the tangent equal 1? Tangent equals 1. Remember, tangent is just sine divided by cosine. Where will this fraction equal 1? Where sine and cosine are equal. Where is that? Pi over 4, 3 pi over 4. Excuse me, 5 pi over 4. 5 pi over 4. Where will tangent be negative 1? And this is really all you have to label. 3 pi over 4, 7 pi over 4. These are the important points to label. This graph needs to be memorized. Not tomorrow, but it does need to be memorized. So, asymptotes where cosine equals 0. Why? Because that's in the denominator. Zeros where sine equals 0. Why? Sine is in the numerator. Tangent equals 1 where sine equals cosine. Tangent equals negative 1 where cosine and sine are opposites. Alrighty, and the last thing I want to do for